Hello, my name is Jacob Magnon, and this is Lab 1 for Physics 2212, and we will be observing the interactions of electrically charged tape. Let's get straight into it. The purpose of this lab is to observe the transfer of electrons between objects, and in our case, tape. Once this transfer occurs, we will observe the charge of the tape when it encounters other objects. Then, we will create a computational model using GlowScript to predict the charge on the tape. Some of the fundamental principles we need to know are Coulomb's law and Newton's second law, and some of the electric force equations are shown here below. In this lab, we are going to make some assumptions about the behavior of the interacting charges. We will assume drag can be ignored and that the charge tape is treated only as a point charge. Also, we will assume that all the tapes used have the same equally distributed charge. Some approximations and calculations include the distances measured and the mass of the tape, as well as the force only acting in one direction. In the main result of this lab, we will see how tape interacts with its surroundings using the mentioned principles and assumptions. Moving on, some observations that I made are that the tape is attracted to a negatively charged pen, and that two pieces of charged tape would repel each other. These led me to assume that the tape is positively charged. For the experiment, the system was the tape A, shown here, and the surroundings were tape B, shown here, and the Earth. Essentially, tapes A and B are charged using a method shown given to us by the lab. And then tape B is hung between two objects. Then tape A is held close to tape B and they repel each other. After that, I measured the distance between the repelled tapes, which we'll use in setting up our GlowScript code. Next, I calculated the charge Q, shown here, using these steps. By knowing the gravitational force and distance between the two tapes in the experiment, we can derive Q, and furthermore calculate the number of electrons on the tape using the charge of a single electron. Lastly, the ratio of electrons to atoms was calculated using this formula here. Moving on to the GlowScript, on the left here I have the needed constants, and on the right I have the calculations of gravitational force, electric force, charge, the number of electrons, and the ratio of electrons to atoms. Finally, these are the results that I gathered from using this GlowScript code. Some possible sources of error in this lab are inconsistencies in my hand measurements, the assumptions mentioned in the beginning, and the approximated weight of the tape. For our first question here, if electrons and protons switch charges, the observed interactions would be the same because electrons would simply take the place of protons and vice versa. Lastly, for the second question, it is important to handle the tapes as little as possible so that the tape does not discharge electrons to your hands and become neutrally charged again. To conclude, in this lab we saw that charges and their interactions can be observed under pretty simple circumstances. Using Coulomb's law, we were able to approximate these interactions numerically and with some accuracy. These forces, although small, can amass to cause large interactions in our world. And that is about all for this lab today. Thanks.